Alright guys, so in this lesson here, we're going to solve optimization problems using the concept in lesson 4.1 and 4.2. For 4.2 particular, we know that this is what we know in 4.2. If we look at the second derivative of a function and it's greater than 0, that tells us that the function itself is a concave up, and then if the function is the second derivative is less than 0, then the function is concave down. Okay, and concave up is sort of look like this here. If you have a graph that behave like this, concave up, and then here's concave down, right? In 4.1, we learned that if we have this type of behavior here, we can look at what value of x that is called the critical value. What value of x is that you the extrema. In this case, we have a minimum extrema, so that's the min, and then this would be the max. Okay, so in these problems here, the ultimate goal is being able to find out whether the function is concave up, concave down. That will yield a maximum or minimum, and essentially we combine both section 4.1 and 4.2, find the critical values for each of those functions to figure out the relative max or min. But the challenging part is come up with the function that we're supposed to maximize or minimize. Okay, so let's get to it. I am gonna skip this example 1 here. This is a typical an algebra 2 question, can be solved using just vertex, but you can also solve this using the second derivative. I'm gonna get into example that a little more relevant to our class here. So in this case here, we have an office supply company sells heavy-duty paper shredders per year at certain price per shredder, and the price demand equation for these shredders is P equals 300 minus X over 30. It's asking for what price should the company charge for the shredder to maximize the revenue, and what is that maximum revenue? So if we're trying to maximize revenue, that is the function that we're supposed to find. There is to figure out what is that revenue function, so we maximize to figure out where the point that that yield the maximum revenue. So we can define the revenue function, but recall we know that revenue is equal to quantity times time, times price, sorry, and quantity is X. That's what we refer to this class. Price is P. So we can construct this function R here is either depends on X or price. It won't matter which one we're looking at. However, if we can define R in terms of P, we have to get P in terms of X first. So if we define this in terms of X, we've already know what P in terms of X already. So it's easy to just rewrite P as 300 minus X over 30. Okay, so that's one way to construct the revenue function there. So that becomes 300x minus x squared over 30. So if the revenue function is 300x minus x squared over 30, we're supposed to maximize revenue. We're supposed to figure out what value of x that yield the maximum revenue. So if we find x, we can backtrack to find p, because p is 300 minus x over 30. So in other words, we're looking for the critical value that yield the maximum revenue. Okay, so to do that, we need to find the critical value for the first derivative. So that is r prime of x equal 300 minus x over 15 is the first derivative. And then we want to set this equal to 0 and solve for that critical value. So we have 300 equal to x over 15. That means x is 300 times 15, 4,500. So this would be 4,500 shredders. So this is the number of shredders the company needs to sell every year to maximize revenue. But again, we don't know if this is the critical value that has a maximum or minimum. So to do that, we need to look at the second derivative. We say that if r double prime of x, let's say r double prime in this case is, it's going to be negative 1 over 15, because we just take the derivative there, and then that just becomes negative 1 over 15. So this means the second derivative revenue function is always less than 0 for all x. That means that the function is concave down. So r of x is concave down. So that means our of 4,500 here, this will yield the maximum revenue. Okay, because if we have a concave down function, we're looking at this type of scenario there. So that will give us maximum. Okay, so let's just summarize what we have so far here. So we asked to maximize revenue. So we construct the revenue function based on x. And then we find the critical value. To do that, we got 4,500, which is the critical value for the first derivative set equal to 0. That's where the slope tangent line is 0. And then we determine that at this value 4,500, it yields a maximum because the second derivative there is less than 0. From 4.2, if the second derivative is less than 0, the function is concave down. If function is concave down, we have a maximum value there. So now to get to the second part of the question, we're supposed to find the price that the company charged you to get the maximum revenue, and we also need to know what is that maximum revenue. So R of 4,500 will give us the maximum revenue for sure, but then we still have to answer what price should the companies charge for the shredders to maximize revenue. To do that, we take the number of shredders that we found that use maximum revenue, plug that into the price demand equation. So 4,500 over 30, and what would that be? 150. Is that price 150 per shredder? So this be price should be 150 per shredder. So now we can say that. So here's the answer. We can say that you know, at price at P equal to $150 per shredder, the company has max revenue of 675,000. And I think I've got that from plugging in. I think this could be wrong here. I think I wanna do the math real quick here. So to get maximum revenue, we plug 4,500 for X. So let's go ahead and redo that there. So let me go to my calculator here. Actually, let me write that down. So we have R of 4,500 is 300. No, sorry, that is 4,500 times 300 minus 4,500 over 30, and then that will give us what? Let's see here. So we got 4,500 divided by 30, and then subtract from 300, so that will give us 150 times 4,500. So 675,000. Okay, so I think my math was right. So this would be 675,000. Okay, so that would be the max revenue. So that's the answer we're looking for. There is price of 150, and will yield a maximum of $675,000 per year. Okay. Right. So I'm gonna do another video after this here, maybe 2 more videos and to show 2 more example, 1 for 3 and this 1 for 4 here. So I'm gonna go ahead and end the video right here.